Hello, everybody, and welcome to episode one of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. Gavin, how's it going?
I'm doing pretty swell, Mike, on this fine evening. How are you?
I am outstanding. I am excited that we have finally gotten this project off the ground.
I
Just
know
a
we've been
very,
talking about this for how many months?
was it August? I think that the formal idea
At
was
least.
conceived, but I mean, we've been as friends, we've all been pushing you to start a podcast to tell your stories for quite a while. And I think the official genesis of this idea was you posted something on Facebook that I just thought was interesting, and so I posted as a comment, "This would be great. You would be a great podcast host," or something to that effect. And that
Yeah.
has basically, over the course of what is this now, 5 months, led us here.
Yeah, so that was back in like late July, and I remember the specific photo was me posting a
Oh,
photo of a
wonderful!
rattlesnake that I found out in the field. Um, and I was like, some days are fun in the field. Some days you almost get bitten by a rattlesnake and die. There's really no in between. Something to that effect. And you like I said, you commented and said, you should really make a podcast. And for all of our listeners who are not, friends with Mike or I personally,
Yes, the thousands of people that don't know who we are that I'm sure are listening to episode one of this podcast.
hey, there might be people who come back and watch it. I
I am
don't
looking
know.
forward to the day
Um,
when that
yeah,
happens.
me too. But yeah, I'm in a master's program studying paleontology. Hence the name of the podcast is that I frequently just talk about all sorts of really cool, interesting things about past life because that's sort of what I do. Um, and I guess people kind of find that interesting. So
I definitely find it interesting, and I'm glad you said that. You said it's paleontology, right?
yes,
It's because I always would get it confused whether you were doing like ecology or paleontology or geology or archaeology. So paleontology is the official is the official. I was going to say job title, but what you're studying.
yeah. So paleontology is this weird mix of geology and biology. So paleontology in general, I'll say geology in general, is one of the most interdisciplinary sciences because you can't really understand how rocks work because, life changes the whole chemistry of the planet. And because of that, you need to understand how it chemically affects the rocks. So, in order to understand the rocks, you need to understand chemistry and physics and biology. And so, it's paleontology is this weird love child between geology and your normal, what most people think of as biology. Um, I remember back around high school when I sort of figured out when or that this is what I was going to do. A bunch of my friends were like, "So you're going to be like Indiana Jones, right?" And uh, no. So that is archaeology, which is really also really interesting, but
Yeah, what's the
that's only
difference?
human things. Um, or human adjacent things. So archaeologists study, past cultures, past civilizations, things like they really only get into different organisms, animals, plants, to the extent that they affected people. So, like the domestication of dogs was, largely figured out by archaeologists, anthropologists type people.
So it sounds as though like archaeology, you could almost put it as like a subset of paleontology, where paleontology is kind of like a catch-all for for everything, and archaeology is just a catch-all for everything from the past as it relates to humans. Is that a fair characterization of kind of the distinction?
No, that's a really good way to anger both a paleontologist and an archaeologist at the same time.
Yes, wonderful. Wow, less than 5 minutes in, and we've already angered. All right, tell me how I'm wrong.
So, paleontology, very, very broadly, is the study of past life. By and large, that excludes everything human. You get into a little paleoanthropology, which is human ancestors, different, species like Australopithecus, which is one that I feel like most people may have at least heard, even if they don't really know what it is. Um,
That'd be me.
so that's basically if I'm remembering correctly, I'm not all that up on my human taxonomy, which is the study of how different things are related. But I believe Australopithecus is the genus that, like the genus Homo, like Homo sapiens evolved from.
Right.
So paleoanthropology is much more similar to like general paleontology than archaeology is. Archaeology is more cultures and interhuman interactions as opposed to, you know, this, old horse, which are mostly what I studied. Um, the sort of
I see.
biomechanics of it, you know. So
I see. So archaeology being like more uniquely human in a way that uh you couldn't study that kind of, culture and the way humans interact, the way you would study the way, fish or dinosaurs or, whatever other organisms interact. There's something uniquely American about archaeology.
just American?
Did I say American? I meant uniquely human.
Yes.
I did not mean uniquely human about archaeology. Yes.
Yeah. And so generally with paleontology, it's really hard to get, especially with animals that we don't really have good comparisons with today, because
Mhm.
it's like older horses, you generally can kind of assume they act like horses,
Right.
but with things like dinosaurs, it is so incredibly hard to get any kind of behavioral, you know, um, interpretations from anything, because behavior doesn't turn into rock like bones do.
Right. And because there's no real analog to today, at least not a perfect. Is that a fair characterization of dinosaurs? We don't have a perfect one to one.
Absolutely, there is nothing today that is like a dinosaur. There are things that
So when people
do
say ostriches are like dinosaurs,
so.
they're they're a little overboard.
I'll also clear this up very early. So birds are dinosaurs. They're not like it.
All birds?
Yes.
Really?
Yep. So
Go on.
once you become something else, you don't stop being what your ancestors were. I like to compare it to like last names. So my mom,
Okay.
her maiden name is different than my last name. That doesn't mean I'm no longer part of that family.
Yeah, so birds have is it like they have a common ancestor, or like there was one particular dinosaur that didn't die out but was able to just continue mating until we have, all the different bird species we have today? Is that kind of what we're talking about here?
So that would be sort of how it would work if birds came around when the rest of the dinosaurs disappeared. But so dinosaurs, besides birds, died out about 66 million years ago. But birds themselves start showing up around 180 million years ago. So,
Oh.
yeah, and granted, they would look not much like the birds that we have today. They would still have tails and teeth and probably still a couple fingers. Um, but they sort of branched off from what most people, I mean, thanks to Jurassic Park, people know them as raptors, which is just a colloquial term. That's not at all an official term. Um, but so they branched off from that same group, um, and then just started doing something different. There was a lot of, the world was a lot warmer, and sort of open grassland type environments didn't even exist at the time because, especially when birds first evolved, grass did not exist. Um, so there was lots of trees everywhere. So they started sort of just flying between trees, catching bugs, doing that kind of thing. Um, and then when the rest of the dinosaurs went extinct about 66 million years ago, like I said, uh, there was a really big, like, anything basically over about 50 or 60 pounds went extinct. And so because birds have to be so light in order to fly, their ancestors made it across that extinction. So that's why the only dinosaurs that we have left are birds.
I don't want to get too bogged down. Was there a particular reason why it was, anything over, roughly 50 pounds that died out at that time?
bigger things need more food.
Okay, and there was just less of it.
Right. So contrary to what a lot of people think, and I know this is not the actual content of the video or the video
Yeah, so we
the
will
episode.
really quick. We'll finish up this conversation, and then episode 1 here. We didn't want to get too bogged down into and in individual things, which I don't think we have been.
No, no.
Um, but we are going to, yeah, I think we're going to spend today talking about kind of the paleontology program that Gavin is in and the different people that he's run into kind of over the course of his studies up to this point, just to give us a sense of his background.
Yeah, we can wrap up this really quick though. So the reason why most larger things didn't make it is because contrary to what a lot of people think, it's really not set in stone that like the meteor impact is what killed the dinosaurs. That's not
I,
at
I
all.
thought that had been established for I thought that was no,
So
no,
it
stop it.
it definitely happened. Like nobody's arguing that it happened, but there's the biggest thing with
That it did. No
paleontology.
one's arguing that it didn't happen.
Right. The
Okay,
biggest thing with paleontology is that the farther back you go in time, the worse the fossils get. Granted, 66 million years is not all that long ago, grand scheme of things, but the only area that we have fossils from like right before that is around where I currently live in, Western North America, areas like South Dakota, North Dakota, Wyoming, Montana. That is the only place in the world that we have rocks and fossils from right before the meteor hit. So, for all we know, dinosaurs could have been extinct everywhere else in the world
really?
except in Western North America. Um, I don't think that's the case, but we just don't have the information to say. And there were also some other things going on in the world. There were some big volcanic eruptions at the time. So obviously, the meteor impact didn't help. But whether that was the sole thing that was the nail in the coffin, there's not really a way to confidently say that. Which is also a very common theme in paleontology. Is like a lot of times we just don't have the best information to make these really strong, conclusive claims.
Yeah, I don't know is a correct answer in paleontology is what you're saying.
Absolutely, absolutely, it is.
Perfect. So I think we can sense a blockbuster episode here. The dinosaurs weren't killed by the meteor, which is going to blow my mind, but we can say that as a teaser for the future. And
Yeah,
I am
absolutely.
looking forward to the different kinds of episodes because, as you and I have discussed, there's going to be kind of I don't want to say a scattershot approach, but we've got a couple different ideas for categories of episodes that I think might work as we go on, and I'm looking forward to kind of what that's going to entail. And I think that we can kind of move from that discussion of paleontology itself and what we do and don't know, or what you do and don't know as a field. I don't want to include myself in this, but I think we can talk a little. I think we can talk a little bit about kind of your story and the people you've met and everything. So from there, how did you first get into paleontology? Was there anything in particular that any books you read or anything that you saw on the internet or people that you met that first kind of kicked off your journey into this field?
So this is going to sound incredibly basic, but as a child of the '90s, as you can imagine, Jurassic Park was very popular.
we are
Yeah.
we are what, 15 minutes into our first episode of a podcast, and we have our Jurassic Park reference.
So okay,
Oh
I
goodness,
will.
yes, yes.
Okay, for reasons I'll get into more later. I've since come to like I love the movie. I really hate what it has done to paleontology. That can probably be an entire episode in and of itself.
And I am looking forward to that episode. Yeah, how old were you when you first saw Jurassic
Oh,
Park?
geez. I would say probably maybe like 8, because it's
Okay,
technically it is technically a horror movie.
really? Yeah,
Yes,
yeah.
like I remember that. Like I remember that sort of surprising me. When I watched it later, just randomly saw it on TV and like clicked info on the remote, and it's listed under like sci-fi horror, and I'm like, I guess.
Yeah, like that's not wrong, but it wouldn't be what I'd first put in. But okay, so you're
Yeah,
8 years old when you first see Jurassic Park, and then what comes next? Are you picking out books? Um,
yeah.
are
So
you
like
dinosaur focused?
um, I feel like as paleontologists, we all sort of start out dinosaur focused, um,
Especially as kids, I assume.
especially yes. And so a lot of it comes from you being a kid. Dinosaurs are so cool because there's nothing at all, like we said, nothing at all like them around today. Whereas there are lots of mammals that have come around since dinosaurs have been extinct that are cooler, in my opinion, but are not nearly as popular because we have mammals around today. You know, most people probably have a pet mammal
Right.
in their house.
So it's something about the unfamiliarity with dinosaurs, you think is part of what makes them so interesting, especially to young kids.
Absolutely.
Okay,
And again, I can get more into that. We can do a specific Jurassic Park episode. We probably should,
absolutely.
realistically.
We should write that down. I don't have any paper near me, but someone should write that down.
Well, yeah. Um, but yeah, so after Jurassic Park, obviously, especially once I discovered that it was actually based off of a book. A lot of people still don't know that. So
Including me until 5 seconds ago.
yeah, so the movie came out in I think '93, and the book came out in I think '89 or '90. And before the book was even published, people were already reaching out to the author named Michael Crichton, who unfortunately is no longer alive. He's someone who I do not wish was dead. Uh, but he before he even finished the book, there were studios reaching out to him to be like, "Hey, we want to turn this into a movie,"
Before he finished the book?
which is super cool. Before he even finished the book, because people, I don't know if like his publisher or whoever was like, "This is one of the coolest ideas I've ever heard," and sort of, pitched it around to a couple different movie studios. Um, but yeah, anyway, so I read the book, and then I ended up buying the book from our library in high school. um,
I didn't know that was a thing you could do.
okay, so what really happened was I let it be overdue for so long, and it just kind of told them that I lost it, and then just gave them money to buy another one. This was pre me having
Oh, of
money.
course.
Like this was me at like
Hmm.
15. So um so I was like, "Hey mom, I lost a library book. Can I have some money?"
Which is, which,
I straight up lied to my parents. If mom and dad, if you hear this, almost a decade later,
well, it
sorry.
was worth it. This
Uh
goes with the whole, it's better to ask for, forgiveness than permission. Your parents probably wouldn't have given you the money to
oh,
actually buy
100%.
the book, but to pay an overdue library fine, well, or a lost book library fine, what are you going to do? There's
Yeah.
there's no way out of that one.
That's still that is literally sitting on my bookshelf behind me
You
right now
still have, yes,
as we speak.
yes, you still have the
Absolutely I
book.
do.
Maybe we can, hopefully we can get a picture of that and post it somewhere, because now I need to see this old library. Does it still have like one of the cards in it that has every name that it signed it out?
I don't know. I've not read it in a little
Okay.
while, but anyway, back to
Right,
the
back to
actual
this. So
story.
you watch Jurassic Park, and you take the book out. You're 15. You have stolen a library book, but paid for it, of course. Um, and I assume by this point you're 15. You're probably what, a sophomore in high school or so.
Yep.
Okay, so you're probably starting to think about going to college, and what you might want to study. So what is that process like for somebody that knows he kind of likes dinosaurs?
So weirdly, for a little bit in high school, like even like during senior year, I thought I wanted to be a physicist because I don't know why. Like I remember watching a bunch of shows on like Discovery Channel or Science Channel, something like that, and thinking like theoretical physics was super cool. And then I looked into it more and realized how much math that is, and I'm like, yeah, that's probably not for me.
Theoretical physics was
Um,
super cool. In case anybody hasn't figured this out yet, Gavin was a real ladies' man in high school, going to lots of parties.
Oh,
Right.
absolutely. But yeah, and then I don't know. I think I just after I figured out that physics probably wasn't for me, then I was like, you know, Jurassic Park was pretty cool, and I always liked the beginning. You know, the part where they're actually out digging up the skeleton,
Right.
which there's also it's one of the more accurate scenes in the movie, but also obviously there's a lot of inaccuracies. We'll save that for the
Of
Jurassic
course.
Park episode. But that was the part that captured my imagination
Hmm.
more than watching a T-Rex destroy a car, as cool as that is. Um, so I actually ended up going to community college for two
Hmm.
years first. And also, just a quick PSA: don't ever let anybody tell you that going to community college is bad. I got an associate's degree without taking out any loans. And basically, anywhere you go, your first 2 years are going to be the same anywhere anyway, more or less. So, and like if something really bad life wise happened while I was working on my 4 year degree, I at least had an associate's degree at the end of the day to fall back on.
I'm glad you brought that up, and I'm assuming this is going to be a recurring theme over the course of our podcast. But the belief in public low cost education is I think something that you and I um,
Absolutely.
both we're both dependent on growing up to get where we are in life now, and you know greatly encourage everybody else at all levels of life. If you are looking to do something, being able to go to school, and not go into debt hundreds of thousands of dollars just because you think it's the right thing to do. I think it's going to be kind of a recurring thing, just how important public education is. And so I'm glad you brought that up.
Absolutely. All the schools that I've been to, my community college, my 4 year school, and now my graduate school are all public, state
Right.
institutions. So
Wonderful. So you go to community college for 2 years and you get that associate's degree. What's the associate's degree in? Is it just a general studies degree? Is it anything specialized?
so when most people think of like a college major, they think, for in my case, would be like biology, geology. Community colleges don't really
Right.
have that. For some
Hmm.
things, they do. But my associate's degree is very long winded. It is, I am an associate of science
Good so far.
uh, in math and science with a science concentration.
Okay.
And I'm pretty sure it's actually liberal arts and sciences, math and science,
That
science
seems like a
concentration.
long way of saying you do some science stuff, but okay, I can get behind that. So you have your two
Exactly.
year degree.
And I loved my time at community college too.
Oh, absolutely. I remember talking to you then, and you really seemed to enjoy what you did there. And then you moved on to a 4 year school. And correct me if I'm wrong, but this is kind of where for you the rubber met the road in terms of you really digging in and saying not only this is what I want to do, but I know exactly what I want to do, and I'm really happy with the path that I'm on. Is that about where where things really started to click and you were sure of what you wanted?
Pretty much. So I will say, even when I got to my graduate school, so paleontology seems like a pretty specific field, but even within paleontology, there's dozens and dozens of more specific fields. There's paleoecology,
Right.
paleoclimatology, um, even just the difference between studying fossil plants versus fossil animals versus fossil bacteria from like, you know, a billion and a half, 2 billion, 3 billion years ago. Um, that's still paleontology, but very different from what I do.
Fossil bacteria.
Absolutely.
Wow.
I mean, the for the majority of Earth's history, there were only bacteria living.
Right.
So, complex life has really only been around for at the maximum 600 million years or so. Most people push that only to like 570 ish, but at maximum 600. The planet's
I was going to make an
4.6.
Earth is 6,000 years old joke, but I decided not
Yeah,
to.
the planet's 4.6 billion years old. Bacteria have been around for at least roughly 3 billion of it. So, little side
Hmm.
tangent there. Anyway, but so I didn't even know fully what I wanted to do within paleontology until I got here to graduate school. But when I got to my 4 year school,
Okay.
I was just wanted to do paleontology. Wasn't sure what or how, because at community college, it's a good way to get your foot in the door for, you know, cheap, like we said, but also not a cheap experience. Like I still had a great experience, and honestly was better prepared for my main upper level classes than some of my classmates were, to be honest, at my 4 year school, who had been
Really?
there the whole time.
Okay.
And like that could just be me being a nerd, like we talked about. Um,
And I wouldn't
but
doubt
like
that.
I genuinely think, well, yeah.
But I mean that seriously though. Like I wouldn't doubt that you would be better prepared than your kind of average person going into something, because this is, you have lived and breathed this stuff for, at this point, 3/4 of your life.
Well, so when I got to my 4 year school, I started as a geology major, and no matter how much you think earth science in high school, like how much you learn there, you do learn a lot. And I have a lot of good friends who are earth science teachers, not at all trying to downplay the really awesome work that they do, but
Here comes the
like
but.
you, well, just because as with every concept, what you learn in high school is really only like a quarter of the truth. So it's like my grad school advisor uh, says really regularly, as you get more education, it's basically unteaching you the things that you were taught earlier that's too simple or an oversimplification.
Right.
Um, for example, this is another thing that we could go into very long, very depth, very, that's not English. We could go very in depth about,
This is our first podcast
is,
episode. The words don't come out perfect every time.
yeah. Um, but something I could go very in depth about is reptiles, because frankly, the group reptiles is nonsense and nobody uses it anymore in real science. Again, we
Really?
can go into that later. Yes, we can go into that later.
All right, write that down
But
along with the Jurassic Park episode and the how the dinosaurs went extinct episode, because we're already coming up with more things I want to know more about.
um but yeah, it's just a series of unteaching you things that were an oversimplification of, getting your feet wet when you were younger slash, at the beginning of your career.
Right.
But yeah, so when I got to uh my 4 year school, I had always sort of thought of myself more as a biology person. I took more biology classes at community college than I did geology classes, but most people told me to be a paleontologist, you start doing geology, because that's not as true these days, but especially, 10 years ago, or at least when my advisors and stuff were in school, um, paleontology was at least mostly geology, because you can't really understand the animals without understanding what the rock tells you about the environment that those animals lived in.
You got to get that background knowledge. You have to get level 0 first before you can move on from
Exactly.
there.
So that's why I went in as a geology major. I ended up adding on a biology major as well, so I have a dual bachelor's of science in biology and geology. Um, but yeah, so I started doing undergraduate research, which if you're in any of our multitude of listeners, um, are in uh,
Yes, all of our listeners.
are in like a STEM field in undergrad in a bachelor's program right now, do research, do undergraduate research. Doesn't matter what it is. If you want to go on,
Can you give me an example?
okay, I'll tell you about the really bad project that I was on that I hated, but taught me
Sure.
some really
Sure.
valuable
Give us the
lessons.
two sentence. Give us the 2 sentence example.
So
Yeah.
my first research project that I did in undergrad was my advisor was one of like a world renowned for knowing lots of things about clams. Yeah, clams.
Like not like the clams any like you or I would just recognize immediately. Nothing special.
Um, they were kind of weird. Uh, like clams in general are fairly boring, but for being clams, these were really interesting in that their shells were only about 2 hairs thick or so.
Really?
Yeah,
Okay.
super weird. Um, so he's world renowned for being like the guy for this group of clams. Um, so obviously, because that's what he knows, my first project was on clams. And again, for being clams, they were really cool. But like as something turns into a fossil, so for example, clams and other things that make shells, snails, they make their shells out of a mineral called wow, I'm so blanking. What a good geology person. Basically, it's calcium carbonate. There's a couple different forms of it. Aragonite is the form that they use when they're alive, um, and it has like a particular crystal structure at like the microscopic level or like the
Right.
atomic level.
Okay.
When it turns into a fossil, that structure changes a little bit because aragonite, the mineral, is not all that stable at like normal conditions. But just by changing some of the atomic structure, it turns into the mineral calcite, which I think most people have at least heard of.
Right.
Um, it's the
I've
stuff that
heard of
like
it. That's
when
about it.
it's the stuff that like when you that clogs up your Keurig basically, or your coffee maker. That's calcite.
This is the kind of breakdown for the common person I am looking forward to here on this show. It's the stuff that clogs up your Keurig.
Right. It's like when you get some water on your mirror and it leaves that crusty stuff. That's calcite. Um,
Okay.
so calcite's more stable. And so what we were looking for was any non-recrystallized shells because the preservation in these was really good and they seemed to be kind of unaltered, but you have to in order to do that, everyone kind of remembers making like looking through a microscope in high school. You just take like the little dropper, put it on the slide, and put the little cover slip on, and you put it under the microscope, and you're pretty much good.
Right.
That is not at all how it works in geology, and I learned that the hard way. Um, so, in order to make a slide to look at through a microscope in geology, what you have to do is cut whatever rock you're trying to look at on a diamond saw. It's literally just a saw blade. So like imagine like a circular saw, a table saw that
Right.
doesn't have like the big like serrations in it,
Okay.
but maybe a quarter inch of the like outside of like the disc just
Right.
has diamonds into the metal.
And can I take a guess and say that's because diamonds are supposed to be like the hardest substance in
They
whatever?
are the hardest material that we know of.
Really?
And so,
Okay.
yes, at least natural material. I don't think they've made like a synthetic material that's harder than diamonds, but I don't know that for sure.
Okay.
But yeah, so and also because it spins really fast, it gets really hot, especially when you're cutting rock. So you have to have water like spraying onto it all the time to keep it cool. So you have to hand cut this little rock on this wet saw, and it sounds dangerous. It's really not. It's very safe actually.
You preempted my next question.
Yeah, no, it's really not dangerous. Like unless you were to like trip and fall into it while it was spinning, you're fine. Um, but yeah, so you cut it into this little brick that will fit onto the slide, and then you have to sand it down or like polish it down using like progressively finer metal grit to make it so it's completely flat. So it'll glue to the slide better and you get a better look at
Hmm.
what you're trying to look at. To
Okay.
make one slide just to this point, because we're about halfway done. That takes a couple hours. Just doing the grit by itself takes a couple hours. And then
Okay.
you
I assume this is just
um,
mind-numbing work.
absolutely like I just threw in some headphones and spent a Saturday. But you then leave them overnight on like a hot plate to get any water out of them. Then you have to mix some
Mhm.
epoxy and then glue it to the slide. However, if your rock does not contain any of the mineral quartz, then you have to put some sand in the outside of the epoxy because that shows you through like a complicated mineral reason that's not important how much to cut off the brick once the epoxy sets. Because
I'm
then
gonna
because
trust you with all of that because it went a little over my head, but I trust you on all of that.
but yeah, so at this point you have a brick of rock glued to a slide of glass with some sand and some of the glue. So then you still have to cut off the rest of this brick and then polish it again to get it down to the thickness that you want. If at any point something goes wrong, say the epoxy doesn't hold when you go to cut the brick, say you polish it too much and take too much of the rock off, you have to do the whole thing over again.
Oh Jesus.
So I had 5 samples that I was supposed to do. 3 of those 5 I had to redo
And where are you in school at this point?
for
You
several
are
reasons.
are you like a
Uh,
junior,
this
senior?
was this was the spring of my first year at my 4-year school.
Okay, so this is your third total year of college.
Third total year. Yeah, I was in undergrad for 5 years total.
Okay.
Um, yeah. So, and then all of this work basically amounted to nothing. We did not find what we were looking for. We did a couple chemical analyses on the rocks because there were some weird things on the rock about the rocks themselves, but also didn't find anything. So, um, well over like a full time week of work, 40 hours, uh, you know, easily 40 hours over the course of a semester, sure. But like while you're doing other
But
things,
still,
that's a lot of time
it's a lot of
and
time to put into something and get nothing out of it. Like that's got to be
nothing,
kind of
literally
disheartening
nothing.
to a young scientist trying to figure out what he wants to do.
Exactly. But it really did teach me a really important lesson in that, like sometimes science sucks, you know, and it also really taught me that,
I think
you
that could be
know,
this episode title. Sometimes science sucks. Episode one. Sometimes science sucks.
like it really does. And sort of, sort of a little fourth wall breaky. I'm in the middle of some sucky science right now in that I'm cramming to get a bunch of data collection for my master's thesis done um, before I go away for the holidays. So, yeah, I have a couple days to measure a couple hundred teeth. Um, yeah,
I am looking
so
forward to
that
recording
I
over
can
the
talk.
holidays and
Yeah, I
hearing
can
about
talk
how
about
this
a
went.
whole. Absolutely, we can spend a whole episode on my master's thesis if I'm feeling uh, arrogant that day. Um, so anyway, that was the end of my first year at my 4 year school. Really disheartened. Um, really did not even plan to continue doing uh, undergraduate research. I was going to tell my advisor, I wasn't going to tell him last semester was horrible. Please don't make me do that again. I was going to respectfully just be like, I don't know, my schedule's pretty full because I picked up the biology major starting that semester.
Hmm.
Or like so the fall of my second year there, my fourth year of undergrad total. Um, I was just be like, I'm too busy. I was also working as a resident assistant at my college at the time, very busy. I was just gonna respectfully be like, I don't have time. But then he came to me and was like, I worked really hard on thinking of a good project. Because I think he kind of knew that I hated it, even though I didn't tell him. I think he just kind of knew.
I'm sure it was pretty obvious to anyone
Yeah.
involved.
Um. So he was like, yeah, I spent a lot of time over this summer thinking about a good project for you because he knew that I was interested in vertebrates. Animals with bones, a backbone, as opposed to, you know, clams. Which he will be the first one to tell you he's not, that's not what he does at all. Even though he is a paleontologist, that's not what he does. Um, so had a really cool project idea that he spent time working on, which for him is kind of saying something. Like I love him to death. He's a really great teacher. Um, but there are some students where you can tell that he just like doesn't like them, which like in college is very much a thing. But for him to like put in effort, outside of when we needed to, that really meant like a lot to me. And the project was really cool. I ended up getting that research published by the Geological Society of America. I presented a poster at a regional conference, so I'm technically a published author
Really?
because of that
This is
research,
news to
which is
me.
super cool. I can technically testify in court as an expert witness if need be.
I don't know when that's going to come in handy, but I'm looking forward to
Oh,
finding
it
out.
never will. It absolutely never will. Um, our friend Melissa actually told me that because her mom's a judge. Um,
I
yeah.
you know I there's got to be some way that this can be useful. What if somebody was like there was like a museum theft or something, and you needed an expert witness on like what exactly it was that was stolen and how valuable and this, that, and the other thing. Is that could work, right?
I feel like they would just use someone from the museum then. Like,
All right, so we need to get you a job at the museum.
I'm applying for one. I'm literally currently in the
Ooh.
application process
Ooh,
of
don't
working
don't
at a
give away too
museum
much. Don't
after I'm
give away
done
too
here.
much in case it doesn't work out. But I am looking forward to hearing the good
Oh,
news
well, I
about
mean, that's
this.
also part of science. Um, a large part of professional science is applying for grants and then not getting them. Um, Like if you have a grant acceptance like record of like 25%, you are a rock star.
Really?
Yes.
And who's giving away these grants?
Um,
Is it the government? Is it just rich people? Is it
um, a good combination of stuff. A large part of it is the government. A large part of it is private people, different organizations like I mentioned, the Geological Society of America, the Society of Vertebrate Paleontology. Sometimes it's even larger museums, such as the American Museum of Natural History in New York City. A lot of
okay?
larger institutions like that have they set aside money to pay people to do X thing, or you can submit an application to them proposing this is the cool research I want to do.
Right.
Here's the money I need. Here's how I'm going to spend that money. Can I have money, please? And some larger institutions have that money and will give you that money. But like I said, if you have an acceptance of 25%, you are like the grant writing god, you know?
Really? Okay. So it's a lot of learning to live with failure.
Absolutely, 100%. For every like scientific paper that gets published, maybe not as much these days, and that's again another whole topic that could be talked about is publishing science. Um,
I have heard a little bit about this, some publishing bias, bias towards things that only work out.
yes, I do not remember the last time like a study was published that just like checked somebody else's results, which is a major part of science.
That's part of the scientific method, isn't it?
Exactly. Like science doesn't work if people aren't checking each other because Joe Schmo could make some crackpot thing saying, for example, there's somebody in paleontology that I know that is not a. To be fair, I've never met him, um, but I'm at least aware of him. But he's published things and talked a lot about Triceratops. You know, probably arguably the most well-known dinosaur, probably after Velociraptor and T-Rex, having like
Right.
quills on its basically its butt.
Butt quills.
Yeah.
Kinky.
Yes. There's to my knowledge, the evidence that he cites is really, really skeptical at best. And at worst, he's just making things up. But science only works because other people are like, well, that doesn't make sense. And then publish their own study saying why that doesn't make sense and putting forward their own thought for why Triceratops does not have quills on its butt.
Or that say, oh, this doesn't make sense. Let's do the experiment. And oh, wow. Like, as it turns out, this guy knew what he was talking about, but you need people to actually go through and do that subsequent research. And
Exactly.
nobody, I assume the credit for, doing things second or third, you're not gonna get the headlines at that point.
Absolutely. And again, I can go into detail about all
So
those
let's
things, but let's get back
I was just
to.
about to say, let's get back to you exactly. So you're now entering your fourth year out of five of undergrad, and your second year at a 4-year school. And your advisor,
Yep.
your advisor is somebody who you said, there was a lot of students that he didn't like, and so it was probably mean something to you that he did kind of take you under his wing. This wasn't, there's something to be said for the good teacher that just goes the hardest they can for every kid, but also, there's something to be said for the crotchety old man that, isn't going to put up with anyone's crap. But he's willing to put up with your
Absolutely.
crap, and he's willing to kind of take you under his wing. So entering your fourth year, your advisor is kind of pulling you back in, and into, at this point, it's still the geology program, correct?
Yep. So even though I was starting that semester, I was a dual major. So I technically did have an advisor in the biology department as well. But I don't think I ever actually even met with him. I had a class with him, but I don't even think that he knew I was his advisee, which was fine because my own geology advisor was, awesome, especially with like academic stuff. Like you need to do, take this class by this semester in order to take this next class when you need to, and all that kind of stuff.
Right.
He was excellent with that. Um, and it's not like I was doing research with the biology department. I was still doing it in the geology department. Um, so I really didn't need my biology advisor. But
Okay.
yeah, it really did mean a lot that he, stuck his neck out there for me and
Mhm.
gave me a project about vertebrates. And just for reference, the reason why, um, I wasn't really doing a vertebrate project before was because there's really almost no vertebrate fossils like in the Northeast,
Really?
which is where we're from, where I went to my undergrad, and there's a couple like geological formations that have things like dinosaur footprints, but the most of the rocks are too old. They're I spent a lot of time doing stuff in rocks that dated back to the Devonian, which is roughly, you know, 380-ish million years ago to early 400 million years ago, I think, somewhere around there, um, which was really well known for not really having a lot of things swimming around. A lot of things were sort of crawling around. Lots of things that look like clams but are not clams. There were lots of fish as well, but they weren't all that common.
Hmm.
Um, but yeah, it was lots of invertebrates, and that's basically the case for the entire Northeast.
And like northeast of North America, you're saying, correct?
Yeah. Yep.
Okay.
Yep. So it was really cool that he gave me a project. It was doing stuff with like this big computer database that just has a bunch of, you
Hmm.
know, this person that's working at some school, say in like Montana, published this paper with he found this type of fossil here, had this information about it. People just take that information from that published paper and put it onto this database. So I was doing some stuff with that,
Okay.
which ended up being super cool. Um, so I did research all
I
that
was gonna say,
year.
so your advisor, kind of, hit the nail on the head with, hey, I think you're gonna like this project,
Absolutely.
and it worked out pretty well for
Mm-hmm.
you.
Yep, and I ended up presenting that at that conference, like I said, um, that spring semester. So we're at the end of my fourth year. Um,
Okay.
and then by that point, by the end of my fourth year, I was done taking geology classes, with one exception. I had to take a field class in the summer of that year, which I, again, will talk about later. Field work is a very large part of geology. Um, but we can talk about that in a different episode. Um,
Hmm.
so then going into my final year of undergrad, my fifth year, I didn't do research just because I was like, at this point, I'm going to focus on applying to grad school, and I didn't at all have a relaxed senior year of undergrad like some people do, um, because technically I had to take some junior level and some senior level classes in biology because I came into it at a weird time. So I had to sort of pack 3 years of a biology degree into 2 years, really a year and a half. Um, so yeah, I was still very busy. So I ended up graduating, and then applied to a couple graduate school programs. And applying to graduate school is very different than applying to, especially in the sciences, to applying to your normal 4 year school. In that you basically have to reach out to the person who's going to be your advisor before you even apply to the school or send anything to the school. So the way it works for sciences is you sort of look up what you want to work on, and then you find the people who are doing that. And so you apply to the school much less than you apply to work with that person.
Okay.
And so I reached out to people at four different schools.
How'd you find these people? Are they like, are they communicators? Are they famous in your field? Do they have cool YouTube video? Like how do you find the people you want to work with in a field like this?
So what I did was go to, because I knew I wanted to work specifically with vertebrate fossils, I went to the Society of Vertebrate Paleontology's website, and they have a whole grad school section of schools with reputable programs.
Hmm.
So then I sort of poked through and sort of looked at what different people were doing at each school. And some schools I just kind of ruled out because I'm like, I don't want to be in that area
Okay.
of the US. It's just like, there are some places where I'm like, I don't really want to live there. Um,
Okay.
so then I came down to, and the place we actually ended up, they actually ended up sending me an email, just like a regular blast email that's like, hey, we see you're finishing up your degree in geology. Have you checked out this school? And I was like, as a matter of fact, I haven't, but I've heard of it. And so I actually checked them out, and sure enough, that's where I am now. Um, yeah, so I applied to four schools. Three of them got back to me, and I got in. One of them just straight up didn't get back to me, which was a little rude.
Okay.
Uh,
Their loss.
Yeah, I'm still a little salty almost 2 years
Would
later,
you like to
but
name that school so that way, everyone just kind of knows what
it
they're
was
getting into?
University of Michigan.
Okay.
University of Michigan.
Is that the
Yeah.
Spartans?
Um, no, that's Michigan State.
Okay.
Wolverines, I believe.
How is it that you know more about sports than I do on this subject?
I have no idea. Anyway, so yeah, I applied to 4 schools, got into 3 of them, and then from there, um, it sort of just came down to a combination of location and money. So, in the sciences, by and large, you don't pay to go to grad school, or at least you pay, but you also get paid. Um, so, the deal that I ended up getting was most of my tuition knocked off, and then I also had a teaching position, teaching a lab, where I got paid a stipend once a month. But the amount that I got paid per semester was more than what remained of my tuition, so it ended up being a net positive.
And you could use that
Um,
for things like living expenses, I assume.
yep, it was literally just a paycheck compared to one of my friends who is a in a master's program for speech language pathology, who doesn't have any kind of like teaching position like that and still has to pay like basically like just 2 more years of your traditional undergrad. And once I learned that that in science you get
Hmm.
paid, or at least it's granted it's you don't get paid well at all, um, but it's enough to exist.
Right, but at least it covers
Yes,
itself.
it's enough to
Right.
exist. Um, so once I learned that, I was like, yeah, cool, science, science is for me. Um, but yeah, so then I picked a program and moved out. He was sort of middle of the road on money because one school was the location was where I wanted to go, but they didn't really offer me any money. They offered turning my out of state tuition to in state tuition, which,
Thanks.
yeah, right. Thanks.
I mean, I shouldn't say. I mean, that's still significant. That's still significant amount of money, I suppose.
It is, but they also didn't guarantee me. They did not guarantee me a teaching job.
You made the right
Yeah.
call.
Um, and then the other school was the least of the 3 locations that I wanted to go to, but the most money. And I'm like, yeah, I'll take the middle ground for both, I guess. And I mean,
Hmm.
I like it. um, so
Good,
that
yeah.
takes me to about here. And so when I before I decided, I emailed a couple students that were working with whichever the various professors at the 3 different places, and just sort of asked them, how is it working with this person? What are they like? Um, you know, are they really old school? Are they really understanding? Are they really strict about deadlines and things? Um, and I'm really glad that I ended up where I am because my advisor is incredible. I love him. He's a little uncouth sometimes. Um, aren't we all?
I have a
Yeah.
question. What does the word uncouth mean?
Not always, not always like politically correct. He can be a little brash.
Ah,
Not in
okay,
like
okay.
it's not like he's saying the N word. He's absolutely not like a QAnon person or anything like that. Um, he just says some things that
Right. He might say the quiet part loud
occasionally.
sometimes.
I think it's mostly just like he's granted he's not like old. He's probably he's like mid to late 40s, but he just grew up in a different time where saying a certain word was okay.
Understood.
But by and large, like I had to do more field work as part of my degree for my master's program this past summer, which was when I found that rattlesnake that we talked about like an hour ago at this point.
That was the genesis for this whole thing starting.
Yeah. um but like he was working on a program or a like initiative, basically a grant application from the National Science Foundation, about ways to make geologic fieldwork more inclusive for um, different groups of people besides the typical burly white dude like myself who wears flannels and khakis all the time. That is your typical geologist. However, that is not, you know, all that inclusive. For example, if you are somebody who happens to be disabled, like in a wheelchair, you can't really do fieldwork as it is structured at most places now. And because of that,
Right.
that is a required part of your degree. So it's basically saying if you're in a wheelchair, you cannot be a geologist, which obviously is not okay. So he was working on a grant proposal to sort of, you know, do some things to try and figure out ways to work around this. He also gave examples of like if you are, for example, somebody who is trans, you're probably not all that likely or willing to want to spend a month out in rural Wyoming. Historically, not great.
I can imagine a couple of other states in the union that I wouldn't want to go if I were trans.
Yes. So like, and because of that,
looking at you, Alabama.
Yeah. I mean, Alabama doesn't really have all that cool geology, and the reason why I bring up Wyoming specifically is that a lot of schools, even schools, like I know, for example, I know somebody who did their geology undergrad at Cornell, and I think he did his field work out in Wyoming or Montana, that area. And so even schools that aren't in the area will go there because the geology in these areas is just incredible. And if you are part of a marginalized community, you may be way more willing to go and spend a month in these places than me, as a 6 foot tall white dude with a beard that wears flannels all the time.
And I think that's important from somebody who's clearly in some kind of a position of power and authority, like your advisor clearly is, to to take those active steps and just say, let's look at who can't be a part of this, because at the end of the day, you want as many people as possible to be a part of whatever your community is. You can have the brightest minds with you, studying with you, learning from them. And the only way you're going to do this is if you are intentional about who doesn't get to be included and how you're going to fix that. And so your professor might not be super politically correct sometimes, but it definitely seems like he's got the right kind of mindset as to how to go about making some larger structural changes to
Absolutely.
that field.
And I guess that sort of more or less brings me to where I'm at now. I've got one semester left, hopefully. Hopefully only one, of my master's degree. I will be defending my master's thesis, which is a whole process in and of itself, where it's basically like you spend 2 years basically coming up with this, anywhere from 30 to, I have one that I'm reading right now that's like 400 pages. Granted, that's really extreme for a master's thesis. That's more PhD stuff, but a really long, basically scientific paper that you publish and you make a presentation on, and you have a committee basically that sort of follows your research, make sure that you check all the boxes you need to check for the school, as well as making sure that you understand the rigors of science and are meeting the basic, necessities of scientific quality. And you basically make this presentation based on your research, you present it to them, and then they grill you and make sure you actually know what you're talking about. And that basically decides whether you get your master's degree or not.
Do you want to give us a little preview as to what it is that you're studying or that your thesis is about?
Horses.
I asked for a little preview, like said, and that's exactly what we got.
Well, I mean, at this point, we're over an hour into the episode, so.
Yeah, so I think that is a kind of a good place to begin wrapping up here. So this is episode 1, just to give everyone kind of the context of what it is we're going to be doing here, and who Gavin, as kind of our resident expert, what his background is and how he wound up.
I wouldn't go that far.
Well, how far would you go? Because I'd go very far with you, Gavin.
Oh,
indeed.
Wait until after I actually have a master's degree before I would call myself an expert in anything.
In the context of this show, between you and I would call you the expert.
That's fair. Okay.
But I do think that's kind of a good place we can wrap up this episode, and kind of moving into the future. For those of you that are hearing this episode, we definitely plan on, as you heard us mention several times in this episode, to have episodes focused on specific things. Again, the title of the podcast is "I Wish You Were Dead," and that can take a lot of different forms. And we plan on exploring quite a bit of them in the future. This was kind of laying the groundwork, and I'm really happy with what we did. Also, because we just recorded the podcast.
Yeah. Again, we've been talking since late July, early August. that we should do this, and here
But
we are. Here we are, like early December. You know, finally getting it done. At least that's when we're
I
recording. Who
definitely,
knows when this will actually go out? But
hopefully, it should be pretty quick. I still have to edit it because we had a couple of quick
yeah,
snafus. There's definitely gonna be a couple of things. Hopefully, we'll be able to add music sometime. I'm reaching out to a few artists to update the cover art, and so hopefully, things end up going bigger and grander. But I definitely have this habit, and I don't know, Gavin, if you're anything like this, of saying I really want to do this thing, and thinking a lot about it, and then never actually, getting it done. And
100%.
absolutely. And so the fact that we have gotten one episode done gives me quite a lot of confidence that we are going to get many more
We're
than one
committed
episode done.
now.
Because absolutely, this was the hard part. So that's wonderful. I think we are good to wrap up with everything. Gavin, any last words for the audience? Any last piece of science? Maybe this can be our closing segment. Is one piece of science advice that Gavin gives to the audience?
Science advice, huh?
I don't know. I mean, if we want to end it with what we said our show title was going to be for episode 1, which was "Science Sucks" or "Science
It
Sucks
really is.
Sometimes."
Sometimes science sucks. However, those sucky times are also just as important. Negative results are just as important, if not sometimes more important, than big, broad, sweeping conclusions, because those very rarely actually happen in science. And so, if you see someone making a really big, broad, new claim in science, chances are that's probably not all that well supported.
You need a lot of evidence. Extraordinary claims require extraordinary evidence.
Exactly. And, similar, like I said, to that, Triceratops butt quill thing, you know, could that have been? I mean, maybe. But until you actually prove what you're talking about, you're just a crazy guy over in the corner yelling about butt quills.
Butt quills. I I think we can leave it there with butt quills. He's Gavin. I am Mike. This has been episode 1 of I Wish You Were Dead. Science Sucks Sometimes. Thank you, Gavin.
Thank you, Mike.